like on my grade sheets, when I'm trying to like darken up lines or whatever, I use rulers all the time just to make nice, clean, straight lines. All right, whenever Jake is done reading, then we will dive into piecewise functions.
Are you done with the whole book?
Yep.
Is it good?
No.
Is that ending good?
Yeah, the ending's a little bit sad, but it's good.
I mean, there, I guess, is a reason to support that he was trying to read in the hallway, because it's like, oh, I want to finish this. And he probably knew Mr. Hudson, is not all about reading books in class. Not a language arts class. All right, graph paper, pencil, ruler if you want. What do we know about piecewise functions?
You said it would be on my Ohio State.
Oh, yeah, that'll definitely be on there.
Fancy stair kind as opposed to the less fancy stair kind.
No, wait, tell me more. Like, use more words.
Well, so you know how like in some hotels and stuff, they got those fancy stairs that don't have like the backs to them?
Okay.
That's not fancy.
No, that is.
You mean like a floating staircase in a way, where they have no kick plate, I think is what you're...
It's really cool.
Okay, so they kind of look like steps, is what you're saying?
Yeah.
But like fancy steps that don't...
Like,
without the vertical.
Yeah.
Jake, how'd you make it this far in your day without a pencil?
Well,
Please.
wait, yeah. How did you do?
I do science.
Yeah, wait.
Then I was it's just better.
Sure.
Oh, so it's just like you write multiple functions and then put them in as one function.
Huh?
Is that what you're getting from reading or from observing the graph we've been given?
Both, and because I accidentally already did this homework.
So, we got goofed up, and this is, my brain wasn't working this morning when you came in, because first off, I was like, why is Jake coming in? I forgot that Friday got screwed up. So 933 was what we were gonna do Friday, and then I never saw you guys, so 933 is today's homework, really.
Yeah, and I did it.
Do you want to try to say that in a different way? Like, or even just say it again. A piecewise function is...
where you put like multiple equations into one function.
So it is a function given to us in pieces. That's why it's called a piecewise function. Here's the misnomer that many people call a piecewise function. But the nickname works in a lot of situations that are piecewise functions.
Isn't sigma also part of the piecewise function?
What does sigma do?
Isn't that the thing that like does the repeated?
Is that the big
addition
E
stuff?
looking thing?
So sigma, like in math, is used for summations, where we're adding up like a lot of things. So that's, to go down the route of what sigma looks like is a complicated route to go down, because sigma says sum all this stuff up, right? So it is, like sigma is like a shortcut operation, right? Kind of like how exponents are a shortcut of multiplication or division, like I have over there.
Multiplication's a shortcut of addition.
Exactly. So it's all like shortcut things. So when I have a ton of stuff that I'm going to want to add together, like say the set of numbers from 1 to 100, which is that famous Einstein story or whatever, that Einstein was like annoying his teacher. His teacher said, go add up all the numbers from like 1 to 1,000.
He said this to her. Get it.
I don't remember how he did it.
Do you hear yourself? Do you hear the disrespect? Because we discuss it. Like we, as a team, talk about all of our students, and you need to be aware, like, you've gotten disrespectful. And I don't think your family, or like, I don't think that some of your, maybe your peers are fine with it. Maybe it's because of your peers. Who knows? But knock it off. I don't want it. I get that you have strong opinions. Do not be disrespectful about it.
Is it 5,050?
I don't know. Because it also depends on whether you go from 1 to 999 or 1 to 1,000.
Oh, it was 1,000.
But we could use sigma for that. So 1,000 makes it a tad bit trickier. If we did 999, that's actually easier, because the 1,000 really kind of gets left over. Or if you add 1 and 1,000 and make those pairs, then your pairs are each 1,001.
Yeah.
Except there's no and. 1,001.
And then you just have half of it. You have half of 1,000, and then you multiply it by 1,000.
Yeah. So piecewise is really, it can be a step function like we see here, but it is really a function given to us in pieces. So do not tell yourself piecewise just means step function. A piecewise could be one that is like linear straight across and then linear with growth and then linear straight across, as long as it still meets the criteria for a function, which what is the number one rule?
Vertical line test.
Yeah, I was trying to figure out how to
You
finish
can't
that
have one
sentence, so
input
thanks.
that gives multiple outputs,
So,
I think. Or is it the other way
in a
around?
situation like this, well, let's clarify, is it input-output or output-input?
It's input output.
So we still have to make sure that when I hit with a vertical line test,
That's why we have those white circles.
that's why we have open points on the ends. So piecewise functions cannot use an input for two outputs because then it's not a function, right? So vertical line test still has to be passed here. So the Horizon Phone Company,
Horizon?
wink,
That's
wink,
not
nudge,
very-
nudge, right?
I don't even. I use H-Mobile.
Right. That's so we're thinking about switching over to H Mobile from our Horizon plan because it's way too expensive. So Horizon Phone Company offers a basic monthly voice plan where customers pay a low monthly fee. Yeah, not anymore. But they must also pay extra if their calls exceed, yada yada. What do these things mean down here?
You're not starting at 0.
Yeah, graph is broken. So you can think of it as we're not starting at 0, or they started at 0 and jumped over a bunch of numbers, right? That's kind of where that jump is that a lightning bolt? So what can we pull from this? This graph tells us a lot of things. What can we pull from the graph? What do we see? The starting cost is $40, and the starting cost stays $40 up until 450 minutes.
And then every, 5 minutes? 6 minutes? And after that?
Well, so
does it
let's
get
track
bigger?
this down then. So this, if I drop that down, and then if I do another,
It looks like
another.
it's about 5. Is it 5? It gets kind of hard to see when there's no, grid paper lines.
right? Annoying.
Yeah, it looks like about every 5 more minutes. No, wait.
So they
Every
actually
one more
split.
minute.
They split $1, right? So right here is probably $40.50 right in there.
So every one more minute you pay another 50 cents.
Ooh.
After 450.
So we said this is indicating that when we jump up to 450 minutes and 1 second, here's why we use these open points. It is literally showing us this is not 451 minutes. It's any minute amount higher than 450. Yeah, so it's literally, as soon as we're higher than 450, we're paying the extra 50 cents. So then we're saying, all right, 50 cents per extra 1 minute, since we said this was 451. And then after 451, as soon as we get that next second, we bump up another 50 cents. So if we were to try to graph this linearly, we'd probably say something like we have a y-intercept of 40, and then,
You could also
We don't really have a
Instagram.
ooh, so wait, we don't really have a slope. What do you mean?
Well, we kind of have a slope of 0 that jumps a bit, but there's no line that's gonna you could try and make a line of best fit, but it'd be ugly.
So if we try to write an equation for the first piece of the graph, just this first up until that vertical line.
Y equals 0 plus 40.
So I'll agree y equals, so let's go ahead and say well, we're talking horizon, right? So actually I'll come back up here. Let's say h of x. Or, we can change, do we want to make it input of minutes? Or something like h of m? We can use any inputs we want, right? We'll often be using x, but makes sense for m. So h of m is 40 when?
When when n is greater than 40, but less than or equal to 450.
What if I only talk to my phone for 1 minute?
Then you pay
So wait, you just said h of m is 40 when m is 40, and I think you said
When m is when m is 0 or greater than or equal to 0.
So between 0 and up to, are we including this point?
Yeah,
Yeah.
because it's dark.
So less than or equal to.
Although I highly doubt they have someone that exactly use 450.
I mean, if Reddit has told me anything, any event, even very small probability. So two twin brothers were racing for a Rubik's Cube competition. The one beat the other by 1/100th of a second. 1/100th of a second. And that's just how accurate their clocks were, right? It could have even been less than that, but the clocks that they had were accurate to the hundredths. So when you're like, oh, what are the chances of that? I mean, it probably happens somewhere.
Well, yeah, there are 7.98. I don't know how many now,
But
but there's
people
a lot
know.
of people.
So this is how we start writing out piecewise functions, is we literally say, here's what the function value is and when the function value is. So then I can't, because I'm kind of out of space unless I make like a little white box to cover up those words. Then what happens to our price? Let's continue to write a few more pieces of this graph. Yeah.
Can I go off on a tangent real quick before I forget it?
I mean, tangents are normally with circles, but okay.
So, I was watching this video and it was talking about something called, I forget what it was called. It was something about the human limit, and it's like if everyone on Earth was doing the same thing every second for 100 years, then there's like a certain probability that something would happen.
You're not doing a great job of giving us details.
It's hard to explain. But then there was like some odds. It was like 10 to the 23rd. Like 1 in 10 to the 23rd.
Oh, and you thought about us talking about the big numbers?
Is the max. And it's like if something is going to be conceivably achieved by a thing, it has to be below those odds.
Okay, and I mean, that makes sense because 10 to the 23rd is a ginormous denominator. You know what I mean? That's
That would be more likely than this, like, what is that?
infinitesimally small.
No, that's only like 1 sextillion or something. Wait, no, it's a bit bigger than that. But it's not a number we don't have a name for.
Well, right, but it is very small. Like, conceptually, if you think of the dartboard of here's 100%, and the point we're talking about, 1 over 10 to the 23rd. Actually, so here's an interesting idea. Like, how big would you have to make the dartboard to see that point? Is honestly, like, that would be a fun, like, somewhat abstract, but being able to then visualize it. All right, cool, because that relates back to last week, but we got to do some piecewise functions, especially because I lost the day last week. So we said that happens under that domain. Write me one more at least of the output of the function that we're getting and under what domain using those domain limiting pieces. Because then our inequality symbols are going to start to change. That's my nice way of saying be careful. This is easy to goof up.
Does the semicolon mean when?
Yeah, like at this point sort of thing. We'll formalize notation here in just a second. Actually, we kind of just leave a gap. Can you what?
Don't you do the curvy brackets?
Yes, we will be using the curvy brackets.
Those are really fun to draw.
I'm just going to erase the piece that I had up here to write the next piece. So now our cost goes to, really, I guess I probably should have called this like C for cost, but we're talking about horizon. Now we go to 40, 50. Under what range? Or sorry, I need to use the proper vocab. What should I be saying if we're talking about X values? What domain, right? So domain starts at 450.
Less
Doesn't it start at 41 though? Because it's not.
Good question. So this function piece starts at 450 and goes to 451. Remember, the change in price was activated by getting above 450. So this M is anything bigger than 450, even though it's 450.00001. You just hung up your phone. It was just barely over. But then that stops, but also includes the stop point at 451. And then each of our inequalities after that will share the same usage of the inequalities. We do not include the starting point. We do include the ending point of it. Now, y'all are smart people. What?
It's like this, Connor.
I'll be honest with you, Connor. Piecewise functions are kind of annoying because the answer to what you're wondering is no. We have to write them out piece by piece. Slow drop of the head. Crap, there was another point. Oh, y'all are smart. There are two nicknames for step functions. There are floor functions and ceiling functions. Any idea which one this would be? Any guess? Why would you guess that it's a floor function?
I'm guessing ceiling functions, it doesn't include the bottom point. Like the bottommost value of x.
I think it's a floor because like you see the like part you don't see, you know? Like floors go up like staircases and ceilings go down like
Ceilings go down.
wait, no, it's probably floor and ceiling for which side the thing's included.
Yeah, it's depending on where the black and white or the empty and the filled in circle are. But I think this is ceiling function because it doesn't include the least most value of x. So it's higher.
At the transition.
I was right.
This, if we jump up and include the starting point, is a floor function. If at the transition point we stay on the function that we were on and then jump up into an open point, right, because this is not included, it's a ceiling function.
Okay, but what would you do if it was like f of x equals that thing, but it's negative x, like so it goes down?
That's just a different function. So this is giving you the notation of floor function versus ceiling function because right here, the greatest integer, so this is literally saying the integer of x, like the output will be equal to the integer input. However, I wonder if it'll let me zoom further. So between 0, like starting at 0, my output is 0. Up until I reach an input of 1, and my output becomes 1. Versus, as soon as I am higher than nothing, 0.001, right? Anything bigger than nothing. This is essentially saying round it up.
And the other one's rounded.
This is saying round it down. All the way through the integer. Not following rounding rules, but literally through the entire integer. Does that make sense? So once we reach 1 point anything, this is saying round down, right? And then the notation kind of helps us say, like, we're rounding down throughout the entire integer.
And also the name, because like the floor is down and the ceiling's up.
Yeah.
Hopefully.
Well, and the floor is lava, so.
What?
My 1-year-old nephew is not old enough to play the floor is lava yet. I tried. He can climb a set of stairs pretty impressively, though.
You got 1-year-old?
Yeah. I mean, he's pretty smart. I don't have any comparison, but he's my nephew, so of course I'm going to think he's pretty smart. All right. So at the point where we get to here, this is what I hopefully have taught well enough this year, is that step function is not a synonymous, it doesn't mean the same thing. It is a type of piecewise function. they're kind of the nicer types of piecewise functions because they're used for a lot of things like how many pizzas should I order for a school event, right? Or like when things aren't broken up to, I'm sorry, life is making you hungry. All right, so this is what piecewise functions are going to look like for us. I want us to take a moment and try to draw these. Creating tables might help us dramatically, especially on B. So notice, and I don't love this. I would prefer if we did some sort of notation like semicolon in between those. But this is saying like under the domain of. So here our domain is going to start at -4 and go up to +5. So your graph there, if you go from -5 to +5, you're probably safe. I want to give you some time to do this on your graph paper, so I might just grab a piece of graph paper to do it on. Wait.
It's both of them?
Oh, I need to restock graph paper. What do you mean it's both of them?
Oh, okay. For the first one, it's both of them. Instead of like one is open.
So you're saying like that is a point and it is shaded in?
Yeah.
Yes. Yeah. 3. -4. 3 is a point. It is shaded in.
So it's a list, not like a equation.
Yeah. You can think of it as like multiple functions composed together if you want, or like graphed on the same axes. But what we're truly saying is it is one function. Like if a company is trying to model, after we sell this many widgets, then, I hate this paper.
Remember like profit?
T-tab paper. Do you want it? Do you use it?
What's a T-tab?
This with the weird tabs. They're for specific notebooks.
Oh, the ones that like jut out when you're trying to put them in your binder?
Yeah. This is T-tab also. Get out of here.
Did you get that from students?
Yeah, I don't think they knew what they were buying. Because unless you bought a very specific notebook, it is not helpful.
Can we put them both on the same graph? Or?
Yes, they all go on this because it is one function. They go
No,
on.
I mean for A and B.
Oh, sure. Yeah, if you want to put both f of x's on the same graph,
I'm gonna name one g of x so I can tell which one is one.
that is a smart idea.
The thing is, the first part of the second one is just a tiny line on my graph because I only did my graph 7 by 7.
The x minus 3 squared plus 1 part.
No, the first part. Oh, shoot, there's wow. Why? Why would you do this to us?
No, we're saying f of x now instead of y.
Okay.
Well, I'm sorry. I have to. It's how I keep my job fun. Make bad jokes.
Okay, so plus 1 starts there. And does it open? I think it opens up.
Sorry, I was going to offer up that you guys could use the baby pieces of graph paper, but I had ran out of that. We're going to compare with each other. So, when you think you have it, see if Connor agrees or see if Machai agrees.
Connor, do you have this?
Or is this what you're thinking it will look like?
No, I think it's going to curve that way. Wait. Oh,
Good,
it's
make a table of input and output values.
I don't have that, but it's probably because I messed it up.
You could make a table of input and output values.
I get the feeling you want us to do that.
If you ever want verification of is this correct, do something else. Right? Don't just stare at it and question yourself.
I think staring at it and questioning yourself is the best approach.
That's on meditation, right? Alright, reminder that in class when we do small problems, if you want, this baby graph paper is sometimes nice to just do a little bit of work.
Maybe. I'm not certain yet. Oh no, but that's open circle.
Did Mrs. Collin was retired last year, right? Like you guys did not have her as a teacher, okay? Because Mrs. Gordon was global culture, right?
I was gonna say something, but then I thought maybe it'd be taken.
Well, because you guys only know her as a guest teacher, but she used to be like a Phoenix team teacher. She started Phoenix.
Yeah, she was the old 7th grade. Well, I don't know. There's no 8th grade global cultures. She was the old global cultures teacher. Did you?
Did I work with her?
No, I think you were talking to Jake, right?
I did a graph and the table.
Well, okay. I want to see your graph because I don't want to make it. You're really bad.
Just show me your graph so I can avoid more work. That is what I just heard.
Wait, am I bad? No, Jake, it's when.
Oh, I'm dumb.
I did it right. What did you get? Oh, that part looks right. That's what these flat lines are. Yeah. I guess technically I should expand that. Do we have to actually, I can just draw an arrow, can't I? The power of arrows. Arrows are great.
I don't get how to do
B? Basically, you can, if you wanted, you can draw both of those like things and then just erase the part that doesn't fit the like area.
What is part, like the bottom part of part B? What is that graph going to look like?
Parabola.
So it's a parabola, right? It's a parabola. It's a parabola. First it was a joke, then I couldn't say it right. So what type of form is that given to us in? It's in a certain form.
Graphing form.
It's in graphing form, parabolas, right? More specifically, it's in vertex form. What does that tell us? If it's in vertex form, what does it tell us?
Where the vertex is?
Well, where is the vertex?
On the right side of 1. Oh, do you like the exact?
Where is it? It's at 3-1.
Oh yeah.
We were not on the same page. My wife and I were not on the same page this weekend. I mean, I'm sure it's a me issue. We left the house, hopped in her car, got halfway where we were going. She was like, "You got a mask, right?" And I was like, "No, doesn't your car have extras?" And it was a whole thing. We did find an extra mask in her car.
Where were you going?
PetSmart to get more Cosequin treats for our dogs.
I'm thinking of getting
I heard that. But do you know what kind you're thinking of getting?
an often pincher, I think.
Okay, I do not know much about them, but do your research to know like if they're prone to health issues or not. That's what, and like I would never go back and not adopt Marley. We just didn't know what to plan for with a German Shepherd. I would have gotten pet insurance if I knew that she was going to be prone to health issues.
I don't think they are.
So,
Insurance for pets?
yes. So talk with your parents about this. If you're getting a dog, it's really smart to think about should you get pet insurance because it covers certain things like annual visits and like things that are already going to cost you money. So having the pet insurance can be a huge help if anything happens, right? Like if you need surgery or whatever. Like we spent $4,000 getting a mass removed from one of our dogs.
A map?
A big old mass, like a growth, right? Like a tumor, but it was non-cancerous, so they really just call it like it's a tumor, but it's a benign.
Mhm.
But yeah, benign. So it was in between. Yeah, it was off one of his rear hips, in between his legs. So it was like impacting his bladder and everything else, and like it was messing up how he walked. I mean, we had to get it removed. All right, back to math. So we know the center of this, and then using a table of values, we could find a few more points and make sure that we do not include the start point here. So these functions we do not talk about as floor or ceiling because they're not step functions, right? We only really call them floor or ceiling functions if we're talking about step.
Because that's a lot
Piecewise.
easier to remember. Because I was going to be like, now, is this a floor or a ceiling?
Nope. Yeah. See, that's why I'm saying.
It could be one of them. It just would be a very weird floor.
And it only happens once, right? The jump only happens once, so it's like, meh, why would we use that name? The reason we use those nicknames of floor or ceiling is so we can more quickly, like, literally this is the notation that we can then use with those symbols, sort of like absolute value, sort of like the other brackets that aren't parentheses, but cut off, right? So this, again, shortcut, right? Efficiency among, like, if you hand something to a mathematician. This really just means round down, round up.
And for a lot of equations, like you were talking about, where you do this kind of thing, it's very useful to be able to know whether or not you're rounding up or down.
Yeah. And, like, if I'm ordering pizza, I'm rounding up, right? I'm always rounding up, so I got extra pizza.
You don't want someone to just be hungry.
Yeah, if I'm buying things from Home Depot, I'm probably rounding down, because, like, I can go get another 2x4, but I don't really want extra stuff sitting around, right? So, like, when I'm doing planning for projects, naturally in your brain, you're gonna think about, is this floor or step, or floor or ceiling? Am I wanting to default to round down or default to round up? Especially when things are not in integer, right? I can't order 3.5 pizzas. I have to either round down or up. I can't order 3.8 pizzas, right? I mean, you could try.
They have different sizes.
Well, okay, sure. It's a good argument. I do. Have you ever done the pizza math? And I promise this. Have you ever done the pizza math of the actual difference between, like, a 10-inch pizza and a 12-inch pizza?
Like, that's their diameter, right?
Yeah. So, like, when you really sit and do the math, it is substantial when you get to, like, 12 versus 14. Or, like, 14 versus 16, right? If you go to, like...
Oh, yeah, because it gets bigger and bigger.
It, like... And not exponentially, per se, but 2 inches is not 2 inches. Is, like, the 2-inch differences are not equal.
The 2-inch diameter pizza is going to be very different from a 4-inch.
Yeah. So it's not equitable changes. All right, let's try this one for an application problem. Elisa's training to run a 5-mile fun run. I don't think the words fun and run go together, but okay. Right? I heard when you guys went on a walk the other day, you just ran the whole time, and I was like, where does Connor get all the energy?
If I say that, you're going to have to call me.
You take, like, caffeine tabs every morning?
No.
That would be really bad. All right, one day she runs from her house to her friend Anna's house 2 miles away. Elisa talks to Anna for 10 minutes while she stretches, and then she runs home. So if Elisa runs at a pace of 1 mile in 10 minutes on the way to Anna's house, let's highlight that in one color so we have that separate in our brain. And on the way home, she is tired. I'll make this green because it's our faster rate. On the way home, she's tired. She runs at a pace of 1 mile every 12 minutes. And in the middle of this, she was stretching while talking with Anna. Draw this on a graph. And do we remember what discrete versus continuous is?
Discrete means it stops. Continuous is when you have the arrows, right? Right, guys?
Other classmates, do we remember the difference between a discrete graph and a continuous graph?
Wait, what are we graphing?
Discrete is when the points are not connected by a line, and continuous is when they are.
Continuous is connected, whereas discrete is dots. Right? That's the brain, like, that's my brain trick, is discrete is dots. D, discrete, dots. C, continuous, connected.
Okay, so...
We're graphing her distance away from home compared to time running. So, we make this graph. Y-axis will be distance from home. Right? Distance from home.
Oh, I just did total miles traveled.
You can. I just kind of wanted the graph to be where it's going to come back down to the x-axis.
Oh, yeah, this is.
It's okay. If you do total distance, your final part will just continue going up as opposed to going down.
I did it as a 4 quartile graph.
Silly.
4 quadrant?
Yeah.
Let's say 4 quartile, and now we're talking about something different.
Yeah. Wait, that's like.
Quartiles is for like in a quartile range and
Yeah.
box plots, yeah. I'm going to use different colors for each part. So she starts at home, so 0, 0. And what would be the like end point of that run to Anna's house?
20 minutes.
Yeah, because you're in 2 miles, right?
Wait,
So-
you ran 2 miles in 20 minutes? Like,
It's
I
not
can
that
run
crazy.
1 mile in 10 minutes.
I was about to say,
I
you
don't think
probably
I can
run faster than that. When you do like presidential fitness tests and stuff, 7 to 8 minutes is like a relatively good pace for a run.
But
You're tall with long legs. My bet is you're
Yeah,
under
but I
10
also have
minutes.
asthma, which slows me down. it's
So
like-
this would be 20 minutes in and 2 miles. This is why I sort of was saying like distance from home. Is then she rests. For how long?
10 minutes.
So now we've got a point that is 30. Still 2 though.
And I think it should be filled in, right? Because that's right when she leaves.
So this is what this problem is pushing us to look at. Sometimes we are the ones choosing whether my blue line or my red line gets that point, but they both can't, right? So we have to make a choice of whether my red line is open and my blue line is filled in, or the other way around. So I want to keep things like relatively consistent.
Oh, yeah, because you can't be both like.
It can't be both at the same time, right? One input cannot have 2 outputs, even if they're the same, and 2 functions can't overlap and still be called a function, right? It'd be the intersection of 2 functions. So then, if I've done that and I make my end point for my red graph filled in over here, my next graph just has to start with an open point. But then she slowed down a little bit. So it took her how long to run home? 24 minutes. And if our y value is distance from home. So when we are creating the functions and the domains for the piecewise, sometimes we are left to do the choosing. Now, the reason I filled in this blue point as opposed to making it the red is like, if we're being very mathematical, she needed like every moment, the whole time to get the whole distance. But that's being really precise. Like, is her house exactly 2 miles away? We're not sure. So you could have flip-flopped this and had blue point open, red point filled in, but one of them has to be there. Because should this graph be continuous or should it be discrete? It should be continuous. She never disappears. Right? If I made both of these open, right? If I made blue open and red open, she stops existing for a moment.
Yeah.
She's no distance
just
from
an
home.
infinitesimally small.
Just a blip in time.
No, because if she was no moments from home, she'd be on the x-intercept, right?
Well, if she completely, there's no point there. There's no x value. There's no y value. There's no anything
She's
value.
not any distance from home. Or
It's like when Anna blinks, right? Like she disappeared for a second. Oh no, where'd you? I don't know. I was hanging out with a 1-year-old yesterday. I'm thinking peekaboo.
because what's that called?
My nephew Finn. Object permanence. Is that what you're trying to think of? Yeah, the kids don't really have. Which was really funny because we're playing, right? My brother's wife went on like a little trip this weekend. So we were playing with my nephew, and my brother was like, "Oh, let's FaceTime Sarah." And I was like, "This is gonna go badly." And he's like, "No, it'll be fine. Let's FaceTime Sarah." So we pull out the iPad, FaceTime Sarah, put it in front of Finn, and Sarah's like, "Hey, Finn." Finn just goes, "Ah!" Like just breaks down. He had forgotten that he missed Mom, right? Like he had been fine the entire day, and just breaks down into tears as soon as he sees Mom on the iPad. And I was like, "Dang it, Brad! I told you we shouldn't do this." Then, this is actually where you will potentially see things like this. So, certain things that you buy, because of limited quantities, as you buy more, it actually gets more expensive. So, HCF is talking about 100 cubic feet. And, like, there's only so much water to go around. So, if you're being really wasteful with your water, and you end up using more than 8 HCF, they're going to bump your price up. So up to 8 HCF, I pay $3.64 per HCF. And this is not true data. This is old. Excuse me. And actually, I forget. There's a different measurement. I don't think it's HCF.
The water comes back. Like, I know it takes treatment energy and stuff, so it makes sense that they would charge for it.
Well, but think of like states out west, they seriously have drought issues.
Yeah.
Like where there's not enough water.
Because they pumped up all the water from underground.
So then they bump the price up a little bit, right? Not too bad. So between 8 to 24 HCF.
That's a big gap.
And then over 24, right? So this is where we would have to be paying attention to the word usage. And I'm not going to make us graph this, especially since we're almost out of time. But so would 24 be included here? No. It's included up there.
Because it says, oh. So
Yeah.
it's open.
So then they bump the price up, yeah, a bit more that you'll pay attention to. But then anything over 36 HCF, and they're like, what the heck? Knock it off. Quit using so much water. And they charge you out the wazoo.
But, like, that's not crazy high for 100 cubic feet of
You would
water.
be surprised how quickly you use 100 cubic feet of... Well, I mean, that's a... I don't know, 100 cubic feet, we could figure out how many gallons that is. 748 gallons. Go home and ask, if you're curious, go home and ask your parents, hey, do you know how many gallons of water we use on a billing cycle? But billing cycles are multiple months. Normally, well, it depends on the company you have, but like we pay our water bill like every 3 months or every 4 months. If they break the year into quarters, it's every 3 months. If they do like trimester things, I forget what they call it. But it's every 4 months then. And that's really just because why should they bill you monthly? It's kind of a waste of effort. All right, that was the whole lesson. Have a wonderful day, guys.